So thank you, everyone, for coming to learn more about this. Like Henrik said, I'm a developer advocate here in Google. And most of the time spent the last 6 months has been helping bring people's apps to Chrome OS and optimize for the form factor and experience. So I'm here to kind of tell you how you can bring your enterprise apps to the same form factor. So when we announced the Pixelbook last October, we also announced that the Play Store is officially out of beta. And so a whole bunch of devices have this functionality right now, including the Pixelbook, most of the higher-end ones, and even some of the lower-end devices, with the plan being that every device coming out in the future will also have the Play Store stock. So it's a great opportunity for you to basically reuse apps you've already built for this type of form factor, specifically if you haven't put a lot of work into your web version. So first, why are we even talking about Chrome OS in terms of the Android Enterprise narrative? There's many different form factors. So we have tablets, we have regular laptops, and we also have 2-in-1s. This gives you the opportunity to choose the form factor to give to your users that fits their use case best. If they're doing a lot of form input or data input, you may really want to get a whole bunch of laptops because keyboard and mouse is going to make that a lot easier. Whereas if you've developed apps already that are very, very touch-focused, tablets are probably the way to go. Again, the platform is really built for productivity, so being able to have a native keyboard and trackpad that people are very used to using is going to allow certain tasks to be done substantially faster. And again, you get to reuse apps that you've already built. A lot of times when people talk about Chrome OS, they think about web. And so bringing Android to the platform gives you a different way to bring the same functionality there, which kind of goes into the next point, which is Android brings easier offline support. Unless you've built a lot of your web apps as PWAs already, it's probably going to be a little bit easier for you to bring offline support to an Android app because it's just kind of natively built into the platform. When you learn Android, you learn stuff about SQLite databases and ways to persist data on the device, whereas offline on web is a little bit more of an advanced topic. The Chrome OS update cycle as well is extremely fast and occurring often. We push updates to Chrome OS the same frequency as the Chrome browser, which is every 6 weeks. And at least as of right now, all Chrome OS devices come through us. So you don't have to worry about any type of OEM delays or carrier delays. Every Chrome OS device is getting updates every 6 weeks, which we're going to talk a little bit later about certain features that aren't on certain devices, and that is generally down to hardware differences. There's no devices that don't get things just due to software. It usually ends up coming down to hardware. So what do you need to do to bring your apps to Chrome OS? Could we say that you have to do nothing? Almost. And forever live long Blobman. First thing that you have to do is, if you're not already uploaded to your managed Play Store, you really should try and push your apps through there. And the biggest reason why is restrictions and configurations work a lot easier when it's going through the Play Store, as the device is able to make sure that the restrictions are there before the app is open and used. Also, when you go and do device administration for Chrome OS devices, as of right now, the only way to sideload an application is if you're already in developer mode. And what that means is you basically have full root permissions on a Linux device. I imagine that if you're giving these devices out to your users or employees at your company, you're probably not going to want them to have full root access or have different applications have that same access. So if you're turning off the ability to be in developer mode, you also lose the ability to sideload. You're going to go through the admin console and approve the apps for your organization. And this is a screenshot of a test organization. I built this test application down at the bottom, and I approved it for my organization only. And so I also uploaded it only for my organization. And if you see on the right there, it also says that it's configured. And so this means that I went in and added the restrictions for this app. And to do that, it's also a little bit different and not as nice. You need to basically upload a configuration text file that looks like that with the keys and values that you need for that app. So as you probably already do it, you scrape the EMM provider or whatever DPC scrapes the values through your restrictions file, and it gives it to you all nice. You don't have to do a lot. On Chrome OS right now, there is only Cloud DPC on the device, and there's no way currently in the admin console for you to scrape the restrictions file from these apps and get the keys and values nicely. So this could be really easy if it's your own app because you built it and you have all the values. If you're using a third-party app, you're going to have to read the documentation and hope that they put that information there. And then optimize for this new environment. There's obviously things that we've never had to think about in terms of just mobile phones. Keyboards, trackpads, stylus, different screen sizes. I'll talk about this more later. You don't have to optimize. Your app will most likely run on Chrome OS out of the box unless you're requiring certain things that the device doesn't have. But for you to really take advantage and give your users the best experience, you have to think about what the use case is for your app, where the best optimizations can take place, and then decide what's most important for you. So I talk about optimize. What does that mean? First, targeting API level 23 or higher is really important. In Marshmallow, we released multi-window mode, and we brought in all this new things about like resizable activities. And so if you're not targeting 23 or higher, if I want to maximize your app on a Chrome OS device, it has to fully restart instead of just going through a configuration change. Really bad behavior. You're going to lose data if you haven't saved it well, or if you've been working on stuff. So the first thing to do is just make sure you're targeting as high as possible. And by November this year, if you're going through the Play Store or even Managed Play, you'll have to be targeting 26 anyway. Make sure you're only requiring features in your manifest that are actually needed. Most Chrome OS devices don't have certain features, such as a rear camera, GPS, accelerometers. So make sure that in your manifest, you're only requiring the features that are actually necessary. And this means not being as specific. You probably don't need a rear camera, you just need a camera. But if you specify a rear camera in your manifest, the application completely becomes uninstallable through the Play Store for this device. At the same time, if you do really need a rear camera, think about doing a runtime check for that feature instead of just completely blocking it from the device. You can probably do a lot of the things in the app without needing to take a photo. Again, like I mentioned before, we have new first-class input methods. We have keyboard, mouse and trackpad, and then stylus. We're going to mainly focus on keyboards and mouse and trackpad in this talk, but there are some devices that are shipping natively with a stylus. And we did announce some upcoming libraries for like zero latency stylus input. So if that is something that you have apps for, whether it's drawing or building plans, it's definitely something to look into. And then multi-window environments and larger screens. Android tablets were a thing, kind of still are a thing, but you probably haven't cared about them for a while. This is kind of a new platform where larger screen devices are coming back, and it really is critical for you to care about the screen real estate you're using and also how you can take advantage of that. There's no reason to hide menus on a 13-inch screen, whereas on a phone, the screen real estate is precious. Yeah, more on this later. So going into some of the code here, there's going to be a lot of code here. Don't worry so much about like reading it all right now. The biggest things to take advantage of are what APIs are being used. And I'm going to post the slides on my Twitter later so you can actually take a look at the code. Also, all the code here is going to be in Kotlin, mainly because some of these samples are really obnoxiously large for no reason. So right-click support is something that is massive with a mouse or trackpad that you're very used to when using a desktop computer, but never really translated to mobile. In mobile, you think of long pressing to get the options for that item, and it usually also turns into a long press and multi-select to do certain things. Long clicking with the mouse and trackpad doesn't really work the same. Nobody's really going to think to do that. So think about bringing some of that same behavior to right-clicking, which is really easy with just the on-context click listener API. It will just handle that I think this was released in 23. If you are targeting anything earlier, you have to do a little bit more work. But this will handle context clicking through trackpad and mouse and any other type of input that has that. The one thing, again, to take a thought of is how you're showing the users these options for when they go through these actions. Like I said, long pressing usually leads to the long press and multi-select option. Where you right-click on a computer, you're usually expecting a pop-up menu. So think about kind of giving that same behavior for those actions where your users are going to expect it. It's going to make their behavior a lot faster, a lot more streamlined. Another thing that we've never had to really think about is hover actions. You've never been able to hover with a finger on a phone, to my knowledge. And so you've never had to think about how do we show somebody that the thing that they're hovering over is actionable, they can do something. And so you can use the on-hover listener here and basically watch for when the user comes into the item and then leaves. This is really big, again, if you're just kind of scrolling around your page and something may not seem like an action item, you want to make sure that the users know that this is something I can click on, drag, do something with, and you can choose what type of UI change you want to make that shown. This is an example from a test app that my team made where hovering over dinosaurs shows that they're clickable, and the outline that appears lets you know that for sure. If you don't have the outline, you have no idea that you can click on these items. There's no change on hover or anything like that. Some of our native components do this by default, but you may find that it's not the right behavior you want. It's not the behavior that you see giving the right action to the user, and so you can go ahead and change it yourself. And then scroll events. On phones, we've always just flung, and it's kind of just done it for us. But you can actually look for the motion event that you're getting and seeing if it's a scroll action. Again, most of our native components handle this well, but what you'll find is if you're building an app that displays documents, plans, PDFs, is that you may want to, if the user scrolled on to that PDF, you may want the scroll to go to the end of the page, and then if you're at the end of the page, go to the next page, which is something that you'll have to build out yourself. The nice thing about this API is you can also check if there's any type of modifiers that are pressed at the same time. So again, looking at documents or PDFs, something that I'm very used to on Chrome is being able to press Control and scroll to zoom in or out. And so you're able to really do this pretty easily without having to worry about having any logic around is Control pressed or not. So looking at keyboard, again, you want your users to be able to go through the behavior in your app as fast as possible, as seamless as possible, and get in and out of whatever functionality is there. One of the things that we take advantage of specifically on websites and stuff is being able to keyboard navigate through everything, whether it's the tab key or the arrow keys. To bring this to your users is actually very simple. So for the arrow key navigation, you set these attributes on your view items. Next focus up, left, down, right. And again, we try and handle this a little bit ourselves and to give kind of what the system feels is the most logical navigation order. But if you're doing anything kind of specific or how you feel like your menus or views should be navigated through, you're going to want to use these attributes to really set that for the user. The other thing that you'll have to kind of think about is if you're going from, let's say, a phone to a tablet layout, you may have multiple fragments that may be there in certain use cases and may not be. So if you're able to kind of check if that fragment exists, if it does, you can set these values on your view items to go to the items in the next fragment. And next focus forward is specifically for tab navigation. Actions on key press. So I wasn't really able to come up with a better title for this, but imagine pressing enter to submit forms. And so you can check on your view if there's a set on key listener, which you can really check for anything. But what we really see this being used for is anyone who has a comment section, a chat section, or any type of feedback area where it's usually a quick chat or a quick text box, somebody's pressing enter and then moving on to. So being able to check for that key code is really easy, and it takes really no logic here. You don't have to worry about if it's pressed up or down, which you used to have to do. This is going to allow people to just breeze through tasks. And you can also do the same thing as we saw in the scroll event, where you can check to see if there's shift pressed or control to basically determine, should I submit this form, should I put a new line in this text box, or anything like that. And then keyboard shortcuts. Most of your users probably do specific things in your apps constantly, and then there's certain things that maybe they do once or twice. Being able to bring shortcuts to this behavior is going to allow people to just get in and out faster and get on with whatever else they're doing, be more productive. And it's something that we're used to on desktops. If you've ever used Photoshop, I think they have like 46,000 shortcuts. And the more you use it, the more things you learn. Same thing with your IDEs. You get really used to what you do all the time, and you learn the shortcuts, and it makes your life substantially easier. So if it's an item or an action that's already in your menu, you can actually add a menu attribute to basically just build this shortcut out for you. So you set the string that will trigger it, and then the specific modifiers that will trigger it as well. So you can determine if it's a Alt, Shift, or Control, or you can actually combine them to make it be a little bit more complicated. If it's not something that's in your menu, you can override the dispatch key shortcut event. And again, there's just static methods here all over the place for no reason. But you just check to see what key code is being pressed and what modifiers are being pressed with it. And you can specify, again, if it can be pressed with any modifier, or if there's two that need to be pressed at the same time. It's pretty easy to build out. And again, you don't have to worry too much about determining if the key's been pressed for a long time, if it's been released. It kind of handles that all for you. So going into window management, this is where we see most of the issues on Chrome OS come in, whether it's bad layouts, apps crashing through resizing. This is where we find most of the apps kind of fail. And it makes sense. Most of the time, you've built really only for phones. Phones are big, but they're not that big yet. They're still generally used in portrait. And this is a very different kind of phenomena and paradigm to think about. So, basically, just thinking about layouts for larger screens, how does your phone layouts scale up? Do you have tablet layouts? Are you trying to have one layout for all? And this is an example. I think this is Play Music. I wish we weren't really good examples for the issues. But there's no way for you to know, what is this track 2 or is this track 3? There's no item dividers. There's no way for you to really follow that line on a larger screen. On a phone, it's perfect. It's right there. It's in your eyesight. But on a larger screen, you just get lost here. There's so much white space. There's no way for you to know what options are there. So think about how you can maybe turn this into a grid layout or do something that a little bit better that makes it a little bit easier for the users to follow and know what they're clicking on, know what they're modifying. Handling both orientations. Again, people generally use your apps on the phone. It's really easy to get away from configuration changes and all that nonsense by just locking to portrait. And so this is what it generally looks like if you lock to portrait and full screen it on a Chrome OS device. You get these super awesome black bars, and you're just completely wasting space. There's no reason for somebody to be using your app on this device because there's no benefit. There's no more information shown. There's nothing there. The biggest area where crashes happen is free-form window resizing. And I'm going to talk more about kind of what actually happens in this process. But again, something new that we've never had to think about. People can turn your app into whatever size they want, whatever aspect ratio they want, whatever orientation they want. They may want a really thin and wide, or a short and wide landscape view for whatever reason. And so being able to handle this is going to allow them to move your app into whatever behavior fits their productivity the best. You use window size and not screen size. Unfortunately, I think the window size APIs still say screen size. Apologies from Google for that. But making sure that you're using the right APIs to get the actual window instead of the total screen. Less assumptions are better. There's no guarantee that your app will be full screened. In fact, we probably hope it's not. That way the user can be productive and doing multiple things at once. They may have it over on the right-hand side of the screen, the left-hand side of the screen. There's no guarantee that if you get the screen size and you start drawing pixels specifically where you want to, there's no guarantee that your app's actually there. And then drag and drop. We released drag and drop a while ago, but I think the form factors of mobile always made that kind of difficult to do. This is the specific form factor that it's made for. I drag attachments into my email all the time. So any type of reporting I'm doing, it's amazing if I'm able to drag images instead of having to go through this upload flow. So this is a form factor where drag and drop actually really lends itself, and people really want to use it. So if you haven't ever thought about implementing it in your apps at all, this is really the time to look at if that would make sense and how that would really work. And we have a whole blog post about drag and drop, but also the specific intricacies, because you can drag and drop from multiple different environments, your Chrome file system into your Android apps and vice versa. So it's a little bit different. So talking about freeform window resizing, so what kind of happens? Configuration changes occur when you cross specific layout boundaries. Think of kind of the size qualifiers to your resources, and there's a GIF somewhere in this slide that will kind of demonstrate where that happens. But configuration changes have always kind of been a hassle, but with rotation, it's generally not that fast. You only rotate your screen that much and that quickly. With freeform window resizing, you can cause many, many configuration changes to happen at once. And on draw is called constantly. Not generally an issue if you are using the native components, because the on-draw is already built out to be as fast as possible. But if you're doing any custom views, you really want to look at your on-draw method and make sure you're not doing extremely, extremely heavy stuff, because your app will break because you'll just get behind. Again, it's just like orientation changes, but substantially more frequent. And so your save and restore state process has to be fast. You're going through these configuration changes very rapidly. And so if you're doing anything extremely heavy, we've seen some apps call the network every onCreate without checking if they've done it before. Try and load extremely huge bitmaps from disk. And so if I go from phone size to full screen, I think it's you're probably hitting 6 layout boundaries and causing 6 configuration changes. If you're doing anything really heavy, you're going to get behind. And generally, your app crashes. And then architecture components help make this easier. I'm sure there's many Jetpack talks and architecture components talks throughout this conference. Things like viewModel and just the lifecycle aware components really make this process a lot easier. You move all of your logic and state to that, and then your configuration changes are really quickly. Those things don't get destroyed and rebuilt throughout the whole process. And this is a GIF that basically just changes backgrounds whenever you hit some of the layout boundaries. And so as you get bigger, you hit less and less of them, but you generally will start out phone size, and then you'll maybe drag to be maximized. And it's really easy to break apps this way. We have a specific code lab for resizing that actually takes advantage of some of the new constraint layout 2.0 features with constraint sets and things that you can take advantage of to make this your layouts a lot simpler, a lot flatter, but also have really nice animations between them. So you want to bring your app to Chrome OS. For a while, the process of doing that was always kind of difficult. Again, to sideload apps to a Chrome OS device, you need to be in developer mode, which means that you need to have complete root access. Most people can't then use their Chrome OS device for work, so what do? You just have a whole bunch of test devices around. At I/O, we announced many things, but one of the things was the Chrome OS emulator, which is currently in preview. I know there's been 7 blog posts throughout the last 2 years about us building this emulator, and there's been very little talk from us about it. And so at I/O this year, we announced that it's actually happening. It's actually being released, and it's currently in preview. I don't know if I have the link here. I don't. I'll share the link in the slides when I post them. And then the other thing that was always something that my team complained about and developers always complained about was just being able to just work with a Chrome OS device just like your phone, being able to plug it into your computer and just push apps. So ADB over USB is now a thing with the two devices right now, the Pixelbook and the HP Chromebook X2. Again, the reason why it's only on these two devices right now is partially finding bugs and stuff that's occurring, but also our hardware thing. So it's not so much we're just not pushing it to certain devices, it's just certain devices don't have this capability. More information on this is on its way. It's still really early, and they're still trying to figure out the best way to make this happen. And then another thing that we announced at I/O was the ability to run Android Studio on Chrome OS. And this is much deeper than just Android Studio. It's the fact of having a full Linux container running on the device. This is still heavily in like early preview. I don't even know if it's considered beta at this point. And only on Pixelbooks, again, due to hardware limitations, but also it's still very early. We're trying to keep as many breaking issues to the people who have Pixelbooks only. Also thought I put the link there, so I'll add that after. This is Android Studio itself for Pixelbooks are also preview. But it's going to be a way for you to just kind of easily build apps and push it right to the device. So kind of recapping, it requires bring your apps to Chrome OS requires little or no code changes. Your get restrictions all works exactly the same. The difference is how you upload those configurations to your DPC. But the only code change you'd really have to make is if you're requiring certain features that the device doesn't have that it just can't run on, whether it's accelerometers, GPS, back camera. And you may need those features, and that's completely fair. And you would just have to make sure that you're giving the teams that need those features and need that app, whether it's regular Android tablets or they're going to be stuck to phones. Again, the restrictions are handled through the cloud DPCs only. There is no other DPC that can be put on the device, so that may change your workflow a little bit. And then on top of that, having to kind of upload that text file and not being able to scrape the restrictions file and get everything in a nice fashion is also a little bit different workflow that you'll have to consider. You get to reuse applications. Especially with little to no work to actually get them running, there's really no reason to not kind of explore what the Chrome OS form factors and platforms can do for your users and employees kind of in those certain environments. And then, think about how you can optimize and bring the more productivity-based features and functions to this platform. Again, I talked about input, resizing, and different window management features, but think about what's actually critical for your users in that application. You may set resizable activity to be false because you don't see this app ever being needed to be resized or worked with anything else at the same time. But having keyboard navigation and being able to fly through really quickly is really critical and will increase productivity in the apps. Think about implementing that. If you have an app that is specifically reading information and bringing it to maybe a text editor, keyboard navigation may not be really all important, but being able to resize well and not have it crash and blow up or lose data is critical for that. So look at that area to optimize. Some of the resources that I mentioned, again, I'll post the slides so you can have these links. And then that is all. Any questions? Feel free to ask. I'll be around today if you don't want to ask right now.
Yes. Thanks a lot. Actually, we have plenty of time for Q&A since the next talk is going to start not before in 15, 20 minutes or so. So are there any questions? Yes, please. Go to the microphone, please.
So about the debugging on Chrome OS devices, there were some rumors about that it will be enabled without switching completely to dev mode. What's the state of that?
So I'm not exactly sure what the current state of that is. It's definitely something that my team's kind of pushed for, and everyone, both internally and externally, is pushing for to figure out a way to make that happen. Because again, putting yourself into developer mode is this big jump that you have to make. You basically have to give full root access to the entire device, and that's always kind of a risky behavior. Not sure on the exact status of that. It is something that the team is looking into and really trying to make happen.
Okay, thanks.